So, let's talk about the silent performance killer in today's global applications. We're calling it the multi-cloud speed bump. It's that super frustrating lag when your data has to travel halfway around the world. And in this explainer, we're going to break down exactly how to solve it.
I mean, it's a feeling we all know, right? You click play on a new show, you load a website, and you just wait. So why does this happen? Especially with these huge apps that are supposed to work everywhere on the planet. Well, it all comes down to one simple, totally unavoidable fact: physics. Okay, to really get this, let's use an example we can all relate to. Imagine a massive streaming service. They're about to drop the most anticipated season finale of the year. We're talking millions of people are going to hit play at the exact same time. This is a classic high-read workload, and it's the perfect stress test for the problem we're talking about. So here is the core architectural challenge. The service's main database, the single source of truth for all that show data, is sitting in a data center in, let's say, Virginia. But the viewers? They're everywhere. They're in London, they're in Tokyo, they're in Mumbai, and every single time they load that show, their request has to travel all the way across an ocean.
And that trip, it is not instant. We're talking 200 milliseconds or even more for just a single round trip. Now, that might not sound like a lot, right? But multiply that by every single piece of data you need just to start the stream: the thumbnail, the title, the user profile. That's how you get buffering, lag, and, well, a lot of unhappy users. So, how do we beat the speed of light? Well, we can't, but we can cheat. And that cheat, my friends, is called caching. I want you to think of it as creating a data shortcut that just drastically cuts down that travel time. In simple terms, a cache is just a small, incredibly fast data store that sits geographically close to your users. It holds a copy of the most popular, most frequently requested stuff. It's kind of like a library keeping the 10 most popular books right at the front desk, instead of making you walk all the way to the back shelves every single time.
And this is where you can really see the magic happen. The slow path? It's that long, painful round trip. The app in Tokyo has to ask Virginia for data and then just wait. But the fast path? The app asks the local cache right there in Asia, gets the data instantly, and boom, you've got a happy user. It's a total night and day difference.
All right, so we're all sold on the why of caching, right? But how do architects actually build these shortcuts? Well, that brings us to the tools of the trade. Now, the two biggest names in the game are Redis and Memcached. Memcached is the specialist. It's just brutally fast and simple, absolutely perfect for caching basic objects. Redis, on the other hand, is more of a Swiss Army knife. It can handle more complex data types and can even write data to a disk, which makes it great for things beyond just simple caching, like, say, leaderboards or real-time analytics. And of course, while these two are the titans of the industry, the world of in-memory databases is huge. There are a ton of other specialized tools out there, but you'll find that Redis and Memcached are the foundational players you're almost always going to run into. Okay, so having the right tool, that's only half the battle. The real magic, the secret sauce, is in the strategy, the pattern you use to keep your cache filled with the right data at exactly the right time. The most common pattern out there is called cache aside. It's actually pretty straightforward. First, the application looks in the cache. If the data isn't there, and we call that a cache miss, the app itself then takes on the job of grabbing it from the main database and then putting it into the cache for the next person who asks. So you can probably see the trade-offs here, right? The big pro is resilience. If your cache goes down, the app can still work, it'll just be slower. But the downside? The very first user to request any piece of data always has a slow experience. Plus, all that logic for managing the cache has to live right inside your application code, making it more complicated. Now, compare that to the read-through pattern. Here, the application gets a whole lot simpler. It only ever talks to the cache. If the cache doesn't have the data, the cache itself is smart enough to go fetch it from the database. This basically moves all that complexity out of your app and into your caching layer. So which one is better? The answer is, well, it depends. There is no single silver bullet here. The crucial takeaway is that choosing a pattern is a huge strategic decision for an architect. You're always balancing the need for ultra-fresh data against your performance goals and just how complex you want your code to be. And this brings us to the big finale. How do you put all this together and actually make the right call for your own project? Let's get really practical. You're building that global streaming app. You know you need a cache. How on earth do you decide on the tool and the pattern?
Well, you've got to answer these 4 questions. For our streaming service, how consistent does the data need to be? For a show title or a poster, a few seconds of being out of date is totally fine. It's not a bank balance. What about latency? Viewers expect a show to start instantly. Anything over a second feels broken, so our tolerance is extremely low. Complexity? Our developers could build the logic, sure, but a read-through pattern simplifies our app, which lets them focus on new features. And finally, cost. Look, running caches globally isn't free, but it's way cheaper than losing millions of subscribers because of buffering.
So if you take just one thing away from all this, let it be this. In a distributed, global world, physics is the ultimate bottleneck. Latency is a function of distance. The only way to win is to shorten that distance, and caching is by far your most powerful tool to do it.
And that leaves us with a final thought. As our systems become more and more spread out across multiple clouds and regions, the very definition of fast is changing. It's not just about the speed of your processor anymore, it's about the location of your data. So the question you have to ask yourself is, are you putting your data where your users actually are?